Good afternoon, everyone. Happy homecoming week. I'm going to try and make this a pretty quick video. I do want to cover something that I didn't really talk about last week. So we're doing multiplication, we're doing division. Last week I showed how to use graph paper to solve the multiplication and division problems, but I want to take a step back for just a second. What we do on the graph paper is based on base 10 blocks. We kind of set it up that way. So let's say we wanted to do 3 times 4. We have 3 groups. Okay, 3 groups. And those 3 groups are going to have 4 in each. I want to keep them separate so we can tell they're different groups. All right. So we have this is literally 3 groups of 4. So it's 3 times 4. 3, 4 times. 4, 3 times. This works, but once you start getting to larger numbers, it's not as efficient to do this, and we're all about efficiency. So the next most efficient thing to do is to organize these 3 groups into arrays. And so that's what we did last week with the graph paper. Each of these models is working towards something more and more efficient. So you see doing that takes a while. And if you've got more than 12, just 3 groups of 4. So here's 3. We have 1, 2, 3 groups, and we have 4, 4, 4. So it's 4, 3 times. For a total of 12. We did that with the graph paper last week. Graph paper, though, doesn't work once you get to a certain amount. Actually, before that, even I wanted to show, continuing with the base 10 blocks. Let's say we have a larger number, such as 9 times 8. 9 times 8, we don't want to go, okay, we got 9 groups, 4, 5, 6, 7, 8, 9. That's just a whole lot of ones to deal with. Even just having the 9 groups is a whole lot. So we use our base 10 division kit, or multiplication. We use a kit like this. And so let's say we had done the 3 times 4. We can put 3 over here, 4 over here, and we line up our blocks with the factors. So one factor is 3, one factor is 4. Basically, we're just going to have 3 groups of 4, just like we did earlier. And again, this works fine for small numbers like this. But once you get bigger, so let's go back to the 9 times 8. Sorry for the scatterbrain. Today was homecoming, so nothing has been normal today. But it was good. Anyway, if you do 9 times 8, you would still want to put your factors on the side. 3, 6, 9 times 4, 7, 8. You could take your time going 1, 2, and doing that 72 times. But actually, no, this one's not going to work. Okay, even that one would be inefficient. Let's say, I apologize once again. Let's say I have 11 times, I'm going to do a small one for speed's sake. 11 times 3. Here, instead of us going 1, 2, 3, 4, 5, all the way down to 11, and repeating that 3 times, just like we have over here, we have a block of 10, which represents 10 of these small ones, plus 1, 1. So it's 11 ones. Instead of using 11 ones 3 times, we go ahead and line it up with this block. If you use this block over here, use this block over here. It just makes sense. But we want what's inside this square to line up with what's on the outside of the square. So right now, this lines up, but we still have an extra row that's not filled in, so we've got to fill that in. So here we have 3 groups of 11, or 11 groups of 3. 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, or just 11, 11, 11. And we have a total of 33. So 11 times 3 gives us 33. But this can also represent 33 divided by 11. And you can use this to solve this problem let's say we have the problem, 33 divided by 11. I would begin by, let's do 33 divided by 3. So what I know is, let me get a paper. You can tell I was very prepared for this video. If I was doing 33 divided by 3, I can rewrite that as a missing factor multiplication problem. I might have talked about that last week. But if 33 divided by 3 equals something, then that means also that something times 3 equals 33. So one of our factors for the problem, 33 divided by 3, or blank times 3 equals 33, is 3. So I can go ahead and make that factor over here, and my missing factor I will figure out as I solve the problem. So what I do in here is I just make 33. So that's 33. I have 3 10s and 3 1s. And now I want to try and line this up with my factor of 3. Well, if I do this, each of these 3 factors has 3 in its group, and then these are just kind of hanging out to dry, so it doesn't work. So what I want to do is I want to make equal groups. So I say, okay, I can give 110 to here, 110 to here, 110 to here. Those are all equal, but I only have 10, 20, 30, so I don't have all 33 yet. So I bring what's left, and I find that the missing factor is 11, because in each of these 3 groups that I made using 33, there are 11. This also works with division problems with a remainder, which is what we did some of that last week. Let's say I wanted to do 35 divided by 3. Okay, same problem. The most efficient way to set it up would be 3 10s and 5 1s. But I've got to try to make equal groups out of it. So I try this, say no, that's these have 3, but then there's a whole bunch hanging out here, so then I will make it equal here. Well, as I start giving the 1s away to try to make more equal groups, I notice that I've got some left over. If I give these away, these 2 have 1 extra, and this one doesn't. So these are going to stay at the side. In fact, I like to put them up here if I ever have a remainder. So then we can find out the answer to 35 divided by 3 gives us 11 with a remainder of 2. And of course, later on, this becomes fractions and decimals and things, but we're not worried about that in 4th grade. All right, let's move on. So we did graph paper last week. This week, we started doing larger numbers. So we started using something called base 10 paper. I'm going to zoom in a little bit here. Base 10 paper is called that because it groups everything into multiples of 10. So you see these large squares on the paper. Inside each square, there are 100 smaller squares, and we know that because there's 10 across here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 10 down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that means we have 10 rows with 10 in each, or 10 groups of 10. So there's 100 in each of these big squares. Well, going back to our problem of like 9 times 8 equals 72, we can use it just like the graph paper, and we can come down 9 and go across 8. 1, 2, 3, 4, 5, 6, 7, 8. And then we close our array. We label, this is 9 down, that's 8 across. We have several options here. We can either count 1 by 1 by 1 by 1, all of these, or if we know our 9s, we can count 9, 18, 27, 36, 45, 54, 63, 72, or our 8s, 8, 16, 24, 32, 40, 48, 56, 64, 72. Or if they don't know those, if they're not familiar with those, they can break this down any way they'd like. Let's say they know they're really good with their 5s. They can take this side and split it. 1, 2, 3, 4, 5. So now this side is not 9. We have 2 smaller arrays now. This is not 9, it's 9 total, but it's 5 plus 4. So maybe they don't know 5 times 8, but if they did know 5 times 8, now they could say in here is 5 groups of 8, so 5 times 8 is 40. Well, if they don't know that, they can split this. Let's say they know 5 times 4. So they count 1, 2, 3, 4. 4 plus 4 is 8. So we have 5 groups of 4 here and 5 groups of 4 here. Well, 5 times 4 in here gives us 20 total. 5 times 4 in here gives us 20 as well. And then here we have 4 groups of 8. Well, let's say they don't know their 8s still. They can split this into 4 groups of 4, or even 4 groups of 2. The beauty of the base 10 paper is they can, well, there's a lot of beauty in the base 10 paper, but one of the things is they can use what they know to find out what they don't know. So then 4 times 2 gives us 8, then we have 8, 8, 8. So then we would add all this together. 20 plus 20 is 40, 48 plus 8 gives us 56, and then 64 is 72. So we're still counting by 8s ultimately in the end. But all of this array, this whole array, totals 72. But if they had just known they're 9 times 8, they can figure it out a lot faster. And they say 9 groups of 8 gives you 72. Now, the base 10 paper, we can do this with the graph paper. The base 10 paper, though, is very helpful when it comes to larger numbers, particularly those in the tens. Oops, that is not the one I wanted. I want this one. So, for example, we have this question. It says, focus. Okay, I'm going to read it anyway. Jerry's doctor recommends that he drink 96 ounces of water per day. If the water bottles he has are 8-ounce bottles, how many bottles will he need to drink to meet his goal of 96 ounces per day? This is exactly what the quiz is going to look like next week. It'll just have different numbers. So I've been trying to tell them, if you are doing a word problem like this and you're not sure whether you're dividing or multiplying, draw a picture and think about it realistically. Okay, so if Jerry has to drink 96 ounces of water, let's say he has 96 ounces in this really big jug, and then he has some little water bottles that are 8 ounces. As he pours from here to here, is he going to be getting more water or less water? If he's somehow magically getting more water, we would do a multiplication problem, 96 times 8, which, believe me, I saw a whole lot of times this week. But when you stop and think about it, as you pour from here to here, and then he drinks the water, it's disappearing. So we're not multiplying, we're getting less, we're dividing. So this can be written as 96 divided by 8 equals something. And to rewrite, we want to rewrite it as a missing factor multiplication problem, because when we know at least one of our factors, we can use it to make an array. So, as we do that, this is 8 times something equals 96. So since we know one of our factors, we know the length of one of our sides of our array. So we can come over here and say, let me grab another. We know that one of our factors is 8. So I'm going to come down and go 1, 2, 3, 4, 5, 6, 7, 8. Now, unless the student knows that 8 times 12 is 96, this requires some trial and error. And again, the beauty of the base 10 paper is that it contributes to, I don't know what I'm saying. The beauty of the base 10 paper is we can experiment with it. 96 ounces, 8 ounces. So if the student did not know their multiples of 8, they could literally just go, okay, I know that one group of 8 is 8, and they think, well, 96 minus 8, has he drank all the 96 ounces? No, he hasn't. But maybe if he drinks another one, and they just do another one, that's 2 groups of 8, so 16. 96 minus 16, has he drank 96? Nope. So they keep going one by one. Theoretically, if they wanted to, and they didn't know their 8s, they could do this all the way across until they got to 96. However, hopefully at this point they're going, this is going to take a while. Maybe if I take this much, because between here and here, I have 24 ounces. Could I take another 24 ounces from the 96? I don't know, let's try it. So 1, 2, 3. They go ahead and take 3 at a time. 24 ounces. So then we had 24 plus 24. These two together give us 48. If we take 48 from 96, have we taken 96 away completely? No, we have not. So they might think, well, can I take another 24 away? And they could do 24 and 24 until they ran out. Or at this point, if they kind of start thinking, well, I wonder, well, 40 plus 40 is 80, and that's still under 90, and then 8 plus 8 is 16. Wait a second, 48 plus 48 is 96. They could go ahead and do 6 all across right here. 1, 2, 3, 4, 5, 6, and come down. And this is still 8 down, but it is 6 across. So we have a 6 by 8 here, and this was, this was 3. So we have a 6 by 8 here, so 6 times 8 inside, we have 48. So then 48 in here plus 48 in here gives us a total of 96. So we have found our total. We have achieved the 96 that Jerry was trying to drink. But where do we find our answer? Well, it's up here. This is the total number of groups of 8. So this is a group of 8, group of 8, group of 8, group of 8, 8, 8, 8, 8, 8. All of these columns, these vertical columns, are groups of 8. So here we have 1 plus 1 plus 1, which gives us 3. And then we have 3 more. 3 plus 3 is 6. 6 plus 6 gives us 12. So then, how many bottles does Jerry need to drink per day to meet his goal of 96 ounces of water? It is 12 bottles, and that is his answer. Now, the students who do know this already might go, hey, 8 down, and I know that 8 times 12 is 96. They can just go on across. And the base 10 paper, if we know that there are 10 between here, and there's 10 between here and here, they don't have to count 1, 2, 3, 4, 5, 6, 7. They can just go 10, 11, 12, and they're already there. And come down 8. Oh, I went down 9. Oh well. That's 8. And so then they have an 8 by 12 array, and that gives us 96. They can do any combination they want to, whatever works best for them. Again, that's the beauty of the base 10 paper. That is the division part. On last week's test, they had the most difficulty on division, and it is because there are so many options. There's so much that you can do differently to find an answer. It's not straightforward like multiplication. However, multiplication, let's do an example. So a cake recipe calls for 15 ounces of flour. Sheila's friend asked her to bake 7 cakes for her bridal tea. How many ounces of flour will she need to bake all 7 cakes? Again, they're going to want to think through this. Am I going to be multiplying? Am I going to be dividing? Well, if you think through this, a cake recipe calls for 15 ounces of flour. This is 1 cake. So we get 1 cake has 15 ounces of flour. But she needs to make 7 cakes. Okay? We're not going to take the cake from this, we're not going to take the flour from this cake to give it to 7 other cakes and say, okay, well, there's 15 ounces of flour total, and we're going to divide that equally but among the 7 cakes. That's not going to work very well. So what we're doing is we actually have 7 cakes. 3, 4, 5, 6, 7. And each of these has 15 in it. So we are not doing 15 divided by 7. We're doing 15 times 7. So 15 times 7 is the equation we're trying to solve. Now 15 times 7. We want to do the first factor in our problem on our side. If they did a 7 by 15 rectangle, they're still going to get the right answer. It's just not technically correct. Not going to go into it right now, but just know that we would, if it's 15 times 7, we want a 15 square long side. So I'm going to go down. Again, counting just 10 from here. I already know this is 10, 11, 12, 13, 14, 15. And then 7 across. 1, 2, 3, 4, 5, 6, and 7. And then bring it down. So this is 15 down and 7 across. Again, they can break this up any way they want to try and figure this out, but I don't recommend counting by 15. Some kids have tried to do that this week with like 16, and sure, they can find the answer eventually, but it's not very efficient. We're going for efficiency all the time. And so because it's base 10 paper, I would recommend making groups of 10. So 15 can be broken into 10 plus 5. So in this box right here, we literally have 10 times 7. 10 times 7. Anything times 10, you shift it one place to the left on the place value chart, and you put a 0 at the end. So if I have 7 and multiply it by 10, I have 7. 7 times 10 is 70. Here, because this is a rectangle, this side is the same length as this side, so this is 7. So we have a 5 by 7 in here, so 5 times 7 gives us 35. Now, to find the total number of squares inside this big array, 70 plus 35, and we have 105. So the answer to 15 times 7 is 105. If you have any questions, because this was a fire hose worth of information, don't hesitate to reach out to me. But again, their tests on Tuesday, this coming Tuesday, will look a lot like this, but with some different numbers. So if you'd like to study, you can type in base 10 paper online, and it should come up with a free copy you can download and print, and you can use that with your child. I know it's fair weekend and homecoming and frog level and all the things, but if you have some time, print off some base 10 paper, make up some problems, and just have your kid try it out. With that, have a great weekend, and see you guys next time.